I'm Keith Sharp. I'm the product manager for 3D-Fabrics, and I'm from the SAERTEX USA in Huntersville.
Okay, can you explain us what 3D-Fabrics is exactly about?
Well, the big thing about 3D-Fabrics is we're trying to get a part that's thick. So we have multiple layers that are bound together by a structural fabric. So we have yarns in the 0 degree direction, and we have yarns in the 90 degree direction, with one more yarn in the 90 degree direction than in the 0. The Z yarn, which is a structural fiber, actually goes around the top 90 degree yarn through the thickness and around the bottom 90 degree yarn. And in doing so, it actually provides a lot of strength, and it actually protects a composite made from a fabric like this from delamination. Well, the 3D fabrics are really good when the composite parts become thick. Obviously, if you're going to make a very thick composite part out of very thin layers, you have to put one on top of the other one, and those are only bound together by the matrix. If with the structural fiber in between them, then that adds extra strength to prevent the part from coming apart from loads that actually would want to split it. As an example, if you make a composite part and then you hit it with a hammer through the distance, it wants to fracture or break all of the matrix in the center, and then it'll eventually become a part. With the 3D fabrics, those Z yarns will hold it together, they'll prevent the crack from advancing, and the part will be much stronger, much more damage tolerant. In the past, we have made 3D fabrics out of almost anything that you could fiber-like. We've made it out of glass, E-glass, S-glass. We've made it out of carbon, both the pan-based and the pitch-based carbon. We made them out of aramids ranging from Tworon to Spectra to Dyneema to Kevlar. We've even made parts that have copper wires in them. Well, the big thing is whenever the composite part becomes thick, then that's where the 3D fabrics provide a very good alternative. One place you could think of would be, of course, wind blade roots, or a large structure like a power plant that would have a floor that would want to replace a steel floor. You could replace it with these very, very thick fabrics. We also, the infusion ability of the fabrics make them useful even in boat hulls. We see that quite a bit. And also storage tanks, large industrial structures, things that need to be thick, particularly that need to be infused, would be helped by a very rapid infusion. That seems to be the largest, the best types of applications. The main difference that we have are that the 3D fabrics have this non-crimp structure, so no waviness at all, just like the SAERTEX non-crimps, but they're relatively thin, and we're able to roll them onto rolls for shipping. They come as little as 1,000 grams per square meter, and we can right now make them as much as 5,200 grams per square meter. 3D fabrics are better for the thinner applications. Often the 3D fabrics can be used in boat hulls because they infuse very, very fast.